Okay, so this is basically a new video. I would try and do this on your own, pause it, see what you come up with, and then watch the video. But it's the same as the previous video. It's just one example. So the first problem, first part is to just identify the formula. So we're doing that. It's a double angle for sine. Two is, what's theta? It's 15 degrees. And now this one says evaluate the expression. Okay, so that's where the difference is. And we can evaluate this because when we plug it in, to the formula from step one, don't ask me why I wrote cosine. It's sine of 2 times 15 degrees. And that's going to give me sine of 30 degrees, right? So that gives me sine of 30 degrees. And while I think about, my pi over, 3, pi over 4, pi over 6, right? Here's our 30 degrees. Oop, screwed that up. Okay, so let's change that real quick. Sorry. That should be pi over 6. So for those of you who need this, I'm writing this down. Okay, and so what's sine? So sine's our y value. So we can evaluate this, and this is 1/2. And if you're showing this work, this one's easy enough that you can even evaluate on your calculator and confirm that you got the right answer. Okay, so that's slightly like the previous examples, but now we're evaluating. Okay, so we're going to actually do, I'm going to do this video, and then I'm also going to do one for sine in a separate video, because it might be too long. Okay, so we did problems like these, and so just to draw a comparison, we had some problems where I'd say, oh, okay, we're going to evaluate sine of alpha plus beta, right? And I would say like sine of alpha is equal to 4/5. Cosine of beta is equal to, 15 over 17, right? And then you'd plug these fractions into our formula, right? So this is for sum and difference formulas. But now we're doing double angles, but it's the same type of problem, just a different formula. So the first thing that I'm going to do is I'm going to look at what's given, right? I'm only given cosine. And what's nice about this is I have 3 formulas to choose from. Well, that may be not nice because you're like, hey, which one do I pick? But part of life is finding something that is the easiest to work with, the most efficient. And so I have these formulas that I can use. I have cosine squared alpha minus sine squared alpha. I have 1 minus 2 sine squared alpha, 2 cosine squared alpha minus 1. Okay, so these are the 3 formulas that I can use. So as I look at these, I notice that only cosine's given. So this one requires sine. This one requires sine, but hey, this one only requires cosine. That's what's given. So I have enough information where all I have to do is plug this in. And don't forget, we're in the first quadrant, so that's a positive answer. So I'm going to use this guy in this problem because it's easier to work with. It's more efficient. I don't have to find any other information than what's given to me. And I'm going to rewrite this so we know that writing it this way is the same as how it's written in the formula. So I know cosine of alpha is 7 over 25. I'm going to square it and subtract 1. Okay, and so now it's just a basic algebra problem, or excuse me, not an algebra problem, but computational problem. So as I go through this, I follow order of operations. So I have 2, 7 squared is 49, 25 squared is 625 minus 1. So I'm going to take 2 times 49, and that gives me 98. So I'm going to go ahead and scooch this up real quick. So I get 2, let me get my pen going here. So I get 2 times 98 over 625 minus 1. Okay, And so, you use your calculator or whatever, and I get, running out of room here, so let me, move this up. So I'm going to get 196 over 625 minus 1. Now you can use your calculator and do 196 divided by 625 minus 1, and then you can convert this to a fraction, and I'm going to get negative 429 over 625. So what this problem is saying is that if I double the angle, what's my new trig value going to be? Okay, so if I have, a 42-degree angle and I double it, well, it's 84, right? So what is the actual trig value of cosine of 84 degrees? The actual ratio doesn't double. We have to go through this process. And some of you are saying, well, cosine's in the first quadrant, so why is my answer negative? So why negative? The idea here is if I have a first quadrant angle, and let's say it's 72 degrees, if I double that, 2 times 72 is 144. So that means my double angle is now in the second quadrant, right? 144 is just an example that I came up with, and so that is how we're going to get a negative number. I'll do one more example. I'll use these same numbers, but we'll do sine instead of cosine.